Alright folks, it's Bass Action, back in action here. In this video, we are going to look at the equation of a circle. And if you've watched my other videos, you'll recall that I did mention that the equation for a circle is actually the same as our distance formula and the Pythagorean theorem. It's just written a little differently. Now, we will go over this formal proof in class of how we get to that same thing. But in this video, I just want to go through how to work with the equation. So this video, we're just going to work with our equation, moving between standard form and general form, and then in the next video, we'll do some actual applications of this. So jumping into the equation of our circle, let's jot that down real quick. The standard form of our equation is going to be x minus h quantity squared plus y minus k quantity squared equals the radius squared. So this is like our distance formula because this would be the horizontal distance. This is our vertical distance on that triangle, and this would be the hypotenuse. Now, what we want to particularly draw our attention to is that the h and the k are going to represent the center of the circle, and the right-hand side is going to be the radius of the circle, but it's going to be the radius squared. Now, jumping into our example here, I'm going to scooch this over a little bit. Jumping into our example, this equation that you see here, this is called our general form. Now, we're not going to typically use the general form very often, but you should be able to recognize the general form. What we want to do is we want to transform the general form into the standard form. And the first thing that I want us to notice in this equation is that I've set this equation up so that everything could be divided by 3. That's not always going to work, but I wanted to draw your attention to the fact that if it can all reduce, you should definitely go ahead and reduce that. So that's the first thing I'm going to do is divide everything in this equation by 3. And that's going to give me an x squared plus a y squared plus an 8x minus a 4y minus a 16 equals a 0. Now, we've talked about completing the square already, and what I want you to notice in this case is that I have 2 squared terms and 2 linear terms. So I have a linear term for the x's and I have a linear term for the y's. That means that we are going to complete the square twice in this problem. And we're going to do a little grouping to make our work a little bit easier for us. So I'm going to say x squared plus 8x, grouping the x's, and I'm going to give myself a plus a blank there. Then I'm going to continue with my y plus my y squared minus my 4y plus again a blank. And then I'm going to take that constant, just like we did with our parabolas, and I'm going to kick it to the other side, and I'm going to put a blank, 2 blanks on the other side so that I can make sure that I balance this equation properly. Now at this point, you should be pretty comfortable simplifying your, completing your square by simplifying this kind of in your head. So you should be able to take this 8 and divide it by 2 and get 16. And then we're going to square it and put it in the blank. So I've got 8 divided by 2 is my 4, and my 4 squared is my 16. Kind of stumbled over myself there. My negative 4 divided by 2 is going to be negative 2. Then I'm going to square that. So in my blank, I'm going to go ahead and put a 4. Both of those values then need to go on the other side of my equation. Now, when I continue with my completing the square, I'm going to have an x plus 4. Remember, that's the b value divided by 2. Then I'm going to have a y minus 2. Again, b divided by 2 squared. Collect all these terms on the other side. 16 and 16 is my 32, plus another 4 is going to give me a 36. So what this is going to allow me to do is graph this in just a little bit, but this will be what we will call standard form. So if the problem asks you to write it in standard form, it's wanting you to do this. Now, if it asks you to find the x-intercept and you're given this form, it's a little bit easier to do because it's all set up and ready for you to go by solving by square roots. So if we want to find the x-intercepts, remember that means let y equal 0. So if I put my y equals 0 in there, I'm going to be left with an x plus 4 quantity squared Inside that parentheses, I'm going to go ahead and I'm going to write this middle step for us right now, and that's going to become a negative 2 squared equals my 36. Continuing on with this then, I know that this negative 2 squared is going to become a nice 4. So I can continue and say x plus 4 quantity squared, subtract that 4, that's going to get me to a 32. And now I can take the square root of each side. Remember, on the left, that's going to give us an x plus 4. On the right, we can't forget that plus or minus, and then we'll simplify that square root of 32 to a nice 4 radical 2. So our x-intercepts are pretty easy to write. Mentally moving this negative 4 to the other side, that's going to give us a negative 4 plus or minus 4 radical 2, comma 0. Those would be my x-intercepts. Now, continuing on, I can do a similar process with the y-intercepts. Same exact idea, except for this time we're going to let our x value equal 0. And when we let the x value equal 0, we're going to end up with a 4 squared. Sorry, I lost my equation there for a second. You probably have it right in front of you still. Then I'm going to have a y minus 2 quantity squared equals my 36. Again, that 4 squared is going to become a 16, so I can go ahead and I can subtract that from each side. On the next step, I'm going to get a y minus 2 quantity squared equals my 20, already ready to set up by square roots. I'm just telling you guys, lots of times students try to expand this whole thing out, and you're making a whole bunch of work for yourself when you do that. So recognize when you can use those square roots. That's going to give us a y minus 2 equals a plus or minus, and then simplify that radical of 20 to a 2 square root of 5. So my y-intercepts become 0, 2 plus or minus 2 radical 5. The last thing that we do want to look at is how to graph. I'm not looking for perfect graphs here, but I am looking for your graph to look reasonably like a circle and not like a football when we're done. From the original equation, or not the original equation, our standard form equation, let's come back up here and take a look at this. And what I want you to recognize is that your center is red from right here, and our standard form was an x minus the h value, which means our x coordinate for our center is a negative 4, and it was a y minus a 2, so the y coordinate for the center is going to be a positive 2. And then, of course, the radius here was squared, so our actual radius is going to be 6. So when we come down here to our graph, we're going to plot that center first, and we're going to plot our negative 4 up 2. And then we're going to kind of do our north, south, east, and west here. So the north and south and the east and west, those are sometimes called the ordinal points. So from that, we can just count up 6. And I can count down straight 6. And I'm going to go right 6. And I'm going to go left 6. And then from here, I like to just kind of sketch in a fourth of my circle at a time. This gives me a little bit nicer looking circle, and it looks less like a football when I'm done. Okay, in the next video, we're going to go through how we can apply and solve some problems beyond just writing the equation for a circle and graphing it.